In today's lesson, we're going to learn about solving systems with substitution. Example 1, how do I solve linear systems using substitution? Remember, solving a linear system using the substitution method, step 1, you solve for one of the equations for one of the variables. Step 2, you're going to substitute that expression from step 1 into the other equation and solve for the other variable. And then step 3, you're going to substitute again the value from step 2 into the revised equation from step 1 and solve. All right, so remember yesterday we did just this, except for we started at step 2. We didn't have to solve one of the equations for its variable. In today's lesson, though, we are going to have to solve for one of these variables in one of the equations, and then we can substitute it into the other. So let's take a look here. We have 3x plus y is equal to negative 7, and we have negative 2x plus 4y is equal to 0. So when looking at this, the easiest variable to solve for would be in this expression this equation right here. So if I went and I solved the 3x plus y is equal to negative 7, let's solve for y here. So I'm going to minus the 3x minus 3x. And we have y is equal to negative 7 minus 3x. All right, so now we have an equation where we have solved for one of the variables that I can substitute into the other equation. So let's take this part right here. We're saying y is equal to negative 7 minus 3x. So that is going to go in the place of this y right here. So we have negative 2x plus 4, and now that whole piece in parentheses, negative 7 minus 3x, and then let's finish the equation, is equal to 0. All right, so now we're going to solve. And we have minus 28 minus 12x is equal to 0. Now we have to continue to simplify. Negative 14x minus 28 is equal to 0. Let's plus the 28. And now we're going to just divide by that negative 14. And we have x is equal to negative 2. All right. So now we need to go back into one of these. I'm just going to take this one right here because that would be the easiest one to substitute it back in there. So I have y is equal to negative 7 minus 3x. And remember, x is equal to negative 2. So y is equal to negative 7 plus 6. Y is equal to negative 1. All right, so we have the point, negative 2 because that's our x, negative 1 because that's our y. So this right here is the solution, negative 2, negative 1. Now, to just double check your work, we could go back up and we could plug it in. Let's erase this. Whoops. Okay, so if we plug this in, this negative 2 where we see x, and then we plug in negative 1 where we see y, negative 2 times 3 is negative 6, plus negative 1, is that equal to negative 7? Yes, and you could do it down here as well. So we'd have 4, so negative 2 times negative 2 is 4, plus 4 times negative 1 is negative 4. Is that equal to 0? Yes. And now then you know that, in fact, this is the solution to that system. All right, so in our next example, we have 2x is equal to 12, and we have x minus 5y is equal to negative 29. So I'm going to solve for the x right here. I'm going to take this one right here, and I'm going to say x minus 5y is equal to negative 29, and I'm just going to rearrange it. X is equal to negative 29 plus 5y. All right, so now we have to plug this. We're going to plug that in where we see this x up here. So I'm going to take the 2, and now x we're saying is negative 29 plus 5y is equal to 12. All right. so we're going to take negative 58 plus 5, oops, I've got I'm sorry, 10y is equal to 12. All right, so we have 10y is equal to 70, and y is going to be equal to 7. All right, so now let's go back up and we're going to plug it in. So in this case, I don't have a y in my first, so let's go into this one. So we're going to take x minus 5 times 7 is equal to negative 29. So we have x minus 35 is equal to negative 29. So let's add the 35. And x is going to be equal to 6. So we have our solution now. We have our x is 6 and our y is 7. And if I went back up there and I plugged it into those two equations up there, this point 6, 7 would be, or is a solution to both of those equations. All right, in this example, let's go ahead and again, I think I'm going to take the second one right here and I'm going to solve for y. I'm sorry, yeah, x or y, it doesn't matter. X plus y is equal to 1. I'm going to solve for y. Minus x, it wouldn't matter. Okay, so we have y is equal to 1 minus x, and then I'm going to now, y is that entire expression right there. So I'm going to come back up in here and have 2x plus, and now it's like 1 times that. So I'm just going to plug in the 1 minus x is equal to 7. All right, so we've got this, and x is going to be equal to 6. And then once again, we're just going to plug it in. I'm going to take the x plus y is equal to 1. And 6 plus y is equal to 1 minus 6, and y is equal to negative 5. So in this case, your answer or your solution is 6, negative 5 to that system. All right, so we have a couple of story problems now. It says that a sledding hill charges $5 for each tube and $8 for each long tube, a long toboggan. Each group spends a total of $107 for 16 rentals. How many of each type of sled did they rent? The first thing I want to do here is I'm going to assign my variables. I'm going to say that x is going to be equal to the tubes, and $8, or I'm sorry, and then I'm going to assign y to the toboggan. All right, so we can rent tubes and we can rent toboggans. And we have two things going on here. We have one where we're looking for the money, $5 for each tube and $8 for each toboggan, and they spent a total of 107. So let's write that first equation. I have 5x for the tubes plus 8y for the toboggans, and that's going to be equal to 107. All right, and then we have a total of 16 rentals, meaning I'd have my tubes and I'd have my toboggans, and I had 16 of them. So let's solve this then with substitution. I'm going to solve this right here. I'm going to rearrange that, and I'm going to solve for x. I could solve for y, it doesn't matter. So x is going to be equal to 16 minus y. All right, so now I'm going to take this part right here, and it's going to go right up into that. So I have 5 times this quantity right here, 16 minus y plus 8y is equal to 107. So we'll then 5 times 16. So you have 80 minus 5y plus 8y is equal to 107. All right, so I'm running out of room here. Let's maybe move, well, over here. So I need to combine those y's. So I have 80 plus 3y is equal to 107. And you have 27. So y is equal to 9. All right, so we have y is equal to 9, meaning that we know that toboggans, so we know we have 9 toboggans. And then now we just need to figure out how many tubes we have. Let's go back up into here, and if I were to plug in that 9, so x plus 9 is equal to 16. Well, what plus 9 is equal to 16? Well, we're going to have 7. So we know that we have x is going to be equal to 7. So we have 7 tubes, and we have 9 toboggans. So in this lesson, we took a look at how to solve linear systems by substitution when you have to rearrange an equation.